Hello everyone. Today we will discuss about the surface integration with example how to find the surface integration to the given vector by using the cube. So here the surface is cube bounded by the lines x is equal to 0, x is equal to a, y is equal to 0, y is equal to a, and z is equal to 0, z is equal to a. And the given vector is f bar is equal to 4x z I bar minus y square j bar plus yz k bar, and evaluate integral over s f bar dot n bar ds, where s is the surface of the cube bounded by these 6 surfaces. Okay, so then how to find the surface integration to the cube is, here cube faces are 6 and all faces are plane faces, so that's why we can use direct formula for the surface integration. And n bar is find from outward drawn normal n bar is parallel to the x-axis. It is I bar directly, n bar is equal to take I bar. In case of it is in opposite direction, we can take, means the surface is opposite direction of the x bar, then we can, means x plane, we can take minus I bar. And going to the same y bar, if you take positive side, that is j bar, and the surface is in negative side, then normal is minus j bar. And next going to the surface is with z bar, and the normal parallel to the z bar, we can take k bar. Then the surface is opposite side of the z, normal is also draw opposite side of the z, then we can take the minus k bar. So because of here surfaces are planes with square shapes, so that's why no need to take the ds separately, then directly we can find the surface integration by using the formula. Because of it is a cube, it is having 6 faces, it is not a curved faces, so that's why we can take directly. So that is, first write f bar is equal to 4x z I bar minus y square j bar plus yz k bar. Here f1 is equal to 4xz, f2 is minus y square, f3 is yz. Then surface integration formula is integral over s f bar dot n bar ds, double integral over s f1 dy dz plus f2 dz dx plus f3 dx dy. So now calculate the double integral over s f bar dot n bar ds for each face of the cube. How many faces for the cube? 6 faces for the cube. So first face is considered as s1 for s1. So in the figure we can identify the s1 is d, e, f, g, d, E, F, G, whatever the face, first we are seeing that in the xy quadrant, that is a first surface S1. So this surface is at x is equal to a. From this is a x quadrant, from x is equal to 0 to x is equal to a distance, we have a plane, that is surface S1. So if you draw outward normal to this surface, we can draw directly parallel to the x-axis. So that's why n bar is I bar. Here an outward normal is n bar is equal to I bar. Otherwise directly we can write x bar is equal to, means this plane is considered as a normal, then that is equal to I bar. But we can draw a outward normal with the surface, no? So that's why from surface we can draw it. So that's why we can draw a normal from this surface S1. So parallel to the x-axis, n bar is equal to I bar. So and here x value is a, x value is a, and derivative of x dx value is 0. So and y limits, What are the y limits? Y limits are 0 to a. For this surface, y limits are 0 to a, and z limits are also 0 to a. So z limits also 0 to a, and y limits also 0 to y limits also on this axis. Y limits also 0 to y limits 0 to a, and z limits 0 to a. X value for this surface, x value is a. So here clearly you can know that x value is a, and z limits are 0 to a. Height, it is considered as height, and the width is 0 to a. So then y limits are 0 to a, and x value is a, z limits also 0 to a. By using that, find the integration. Here dx value is 0. Dx value 0 means in our formula two terms are zeros, because of here dx 0, here dx 0, we get only f1 dy dz. So f1 dy dz. Okay, so and also if you talk about the projection, then projection is also in yz plane, because of the surface is in xy plane, so that's why projection is also yz plane. Directly we can write the yz by n bar dot I bar n bar value is I bar, so I bar dot I bar is 1. So that's why directly we can write from formula f1 dy dz. So here what is the f1? F1 is 4xz. Substitute it, we get integral z is equal to 0 to a, y is equal to 0 to a, 4xz dy dz, but x value is a, so that's why substitute it. 4a is constant, right outside, z is equal to 0 to a. And next integration with respect to y, here integral dy is y, limits are 0 to a, and z dz. So substitute the limits, we get a, 4a into a, 4a square. Z integration is z square by 2, limits are 0 to a. Then 4a square into a square by 2. And that is here 2 cancel in 4, then we can get 2a square into a square, that is 2a power 4. That is the first value, surface 1 value. So then next one, surface 2. Going to the surface 2, what is the surface? Opposite face of S1. So this is S1. So opposite face is OA BC. So that is S2. So then S2 at x is equal to 0. So S1, S2 we are talking with x plane. So that's why it is this plane at x is equal to a, this plane at x is equal to 0. That's why that is the opposite side of the x. So that's why n bar value is minus I bar. If you take outward normal for this surface, OA, BC, then draw outside, that is also parallel to the x-axis, but it is in negative side. So that's why we can take n bar is equal to minus I bar, and the plane at x is equal to 0. So that's why dx also 0, same as it is. Then two terms are zeros in f bar dot n bar. So then we can get only one term, that is f1 dy dz, and also f1 having x, so x value is 0. So that's why total integration value is 0. Next, going to the surface 3, a b e f. If you take a surface 3, this is the this one, a b e f is the third surface. If you consider as a third surface, then this surface at y is equal to a, and z limits are 0 to a, x limits also 0 to a. Then we can take, and what is the n bar? Unit normal vector drawn from this place to drawn outside. It is parallel to the y-axis in positive side, so that's why it is j bar. Then you can write y is equal to a, n bar is equal to z bar, dy value 0, x limits are 0 to a, z limits also 0 to a. If dy is 0 in our function dy terms are 0, so only we get one term f2 dx dz or dz dx. X limits 0 to a, z limits 0 to a, and also f2 value is minus y square, substitute it, y value is a, then minus a square is constant right outside, integral dz is z, so then substitute the limits 0 to a, that is a, minus a square into a minus a cube right outside, and also integral dx is x, so limits are 0 to a, then a cube into a, then minus a power 4. So that is the third surface value. Then next going to the for S4. S4 means it is the opposite of S3. Then opposite of S3 means then the surface at y is equal to 0 and dy value 0, and opposite outward drawn normal is opposite of j bar, so that's why means y bar, that's why we can take n bar is equal to minus j bar. X limits are 0 to a, z limits also 0 to a, then integral S4 f bar dot n bar ds is equal to double integral over r4 f2 dz dx. Because of dy value 0 means two terms are zeros in our integration part, so only we get f2 dz dx. So then we can get integral x is equal to 0 to a, z is equal to 0 to a, f2 is minus y square, but y value 0, integration value is also 0. Next going to the fifth surface. Fifth surface means upper part of the cube. So that is S5, consider as S5. In our figure EBCD is the S5, and upper part means for the cube upper part at z is equal to a, so that's why z value is a and dz is 0, and if you take outward normal from that plane, then it is parallel to the z axis in the positive direction, so that's why n bar is equal to k bar. X limits are 0 to a, y limits also 0 to a. If dz is 0, in our f bar dot n bar two terms are zeros, we get only f3 dx dy, and the limits are x is equal to 0 to a, y is equal to 0 to a, and f3 value is yz dx dy, z value is a is constant right outside, and the integration with respect to y to the y is y square by 2, limits are 0 to a, so then a square by 2 right outside, integral dx is x, so then substitute the limits 0 to a cube by 2 into a power 4 by 2. This is the fifth surface, and sixth surface is opposite side of the fifth surface, that is OAFG from the figure, and then means a down surface of the cube, so the last down surface is at z is equal to 0, so that's why dz is equal to 0, n bar is equal to minus k bar. Because of if you draw a outward normal, that is opposite side of the z bar, then it is minus k bar. So S6 f bar dot n bar ds is equal to double integral over r6 f3 dx dy. Because of dz is 0, two terms are zeros, f3 dx dy we get, and x is equal to 0 to a, y is equal to 0 to a, yz dx dy, but z value is 0, so that's why integration value is 0. So simply we can find the surface integration because of the given surface is with 6 faces, and it is a cube, and the surfaces are plane surfaces, not a curved surfaces, so that's why directly simply we can find the n bar, and we can substitute the dx dy dz values in the given formula, and we get the 6 surfaces value. Total surface integration value is add all 6 surfaces integration value. Integral over s f bar dot n bar ds is equal to double integral over s f bar dot n bar ds is equal to double integral over r1 f bar dot n bar ds plus double integral over r2 f bar dot n bar ds plus double integral over r3 f bar dot n bar ds plus double integral over r4 f bar dot n bar ds plus double integral over r5 f bar dot n bar ds plus double integral over r6 f bar dot n bar ds. So that is 2a power 4 plus 0 plus a power 4 by 2 plus 0 minus a power 4 plus 0. Then simplify it, LCM is 2, we get 3a power 4 by 2. Why I take the R1, R2, R3? So then our surfaces consider as the regions. So then because of we write limits for the region, so that's why R, because of here we are not discussing about any projections. Directly we can take from the outward drawn normal, then directly we can take the f bar dot n bar and ds, and we can find the dx values also, dx dy dz values also by using xy values. X is equal to 0, then dx is 0, x is equal to a, dx is 0. So that's why we can write two terms are zeros. Just simply we can take one term from f1 f bar dot n bar ds. Simply we can find the surface integration for the cube. That's all for today.